All right, here we're looking at the reciprocal function. The reciprocal function has the equation f at x, here we go, f at x equals 1 over x. So this function has the domain. Now look carefully, the domain here has, in interval notation, will go from negative infinity up to 0, not including, and then again it jumps and goes from 0 to positive infinity. The range, so the y values, are very similar to the domain. In fact, they're exactly as the domain because of the horizontal asymptote. So the asymptote breaks the graph into two parts. Now, levels of increasing. What is this function doing? If you move from left to right, you can see that the y values are decreasing on this side. And again, from this side, you're looking at the y values are also decreasing. So there are no increasing intervals, and it's strictly decreasing. It's decreasing on the same domain as the original domain. It's continuously decreasing from negative infinity to 0, and again, from 0 to infinity. Now, asymptotes, we can clearly see that there's an asymptote at x equals 0, which is the horizontal asymptote, and y equals 0, which is the vertical asymptote. X-intercepts, there are none because there are asymptotes on both the x and y axis. Symmetry. This particular graph, if you reflect it horizontally, will not equal the original function. But if you take that horizontal reflection and reflect that vertically, guess what, folks? You will end up with the original function. So in this case, our reciprocal function is odd. It has an odd symmetry. And we also proved this earlier on when we tried to prove symmetry, and we used the reciprocal function to prove odd symmetry. Finally, end behavior. In behavior, there are 4 arrows. If we count the number of arrows, there are 4 arrows. Therefore, we must describe end behavior for each and every single one of these arrows. So, as x approaches negative infinity, let's start with the negative infinity, y approaches 0 from the negative side. As x approaches 0 from the negative side, y approaches negative infinity. All right, the next one, as x approaches 0 from the positive side, y approaches infinity, positive infinity. And the last one, as x approaches positive infinity, y approaches 0 from the positive side. All right, so again, when we're looking at in terms of x, we can see these numbers here, for example, looking here, that what we're looking at is as x approaches, so here, look at the arrow. So as x approaches negative infinity, the y value is approaching 0 from the negative side. As x approaches 0 from the negative side, the y value is approaching negative infinity. As x approaches 0 from the positive side, y approaches infinity. And finally, as x approaches positive infinity, the y value is approaching 0 from the positive side. And this is the description of the reciprocal function. Now let's move on. Now what we're looking at is the root function. So that is f at x is equal to the root function. What is the domain of this? Well, the domain of the root function is x goes from 0, including the 0, so it's square bracket 0 up to infinity. Now, the range also goes from 0 to infinity. And don't forget, it has a hard stop at 0. The function is increasing from 0 to infinity, across the domain, the full domain, from 0 to infinity, but it definitely never increases. So from 0, for increasing and decreasing intervals, what we have to remember for increasing and decreasing intervals is that it's always round bracket. And it's not decreasing at all. Asymptotes, there are none. X-intercepts and y-intercept is the same value, 0, 0, for both the x and the y-intercept. Now, symmetry, is this even, odd, or neither? Well, reflected horizontally, you'll notice automatically it is not even, and then you take that horizontal reflection and reflect it vertically, and that again is not odd, so therefore the symmetry is neither even nor odd. And finally, the end behavior. What's happening? Well, this is very important. Even though there's no arrow here, there is an end that we have to look at. What is this end doing? As x approaches 0, from the positive side, y approaches 0 from the positive side. Okay, y approaches 0 exactly, so it equals 0. And then finally, as x approaches positive infinity, y approaches positive infinity as well. Okay, and important to note that there is no other side, so as x approaches negative infinity, the y does not exist. There is nothing past that 0 value, because remember that the square root of a negative number does not exist. All right, let's look at the next example. Okay, so let's look at this one. This is the cubic function, so f at x is equal to x cubed. So the cubic function, the domain for the x is x belongs to real. So in interval notation, it goes from negative infinity up to positive infinity. And then the range, y, also goes from negative infinity up to positive infinity. Now, increasing this function, if you look from left to right, it's continuously increasing. So it increases across the entire domain. All right. And then it doesn't decrease ever. There are no discontinuities. The x-intercept and y-intercept are the same values. Then that is at the origin, 0, 0. Symmetry. Now, we reflect this horizontally. It is not even, but we take that horizontal reflection and reflect it vertically, and we find out that this has an odd symmetry. It is odd because the reflection vertically and horizontally will result in the original function. And behavior, this one's relatively simple. It's the same as the line. So as x approaches negative infinity, y approaches negative infinity. And as x approaches positive infinity, you're looking at the y values approaching positive infinity. All right, we're done this one. Let's go on to the next one. So we're now looking at the linear function. So that's when f at x is equal to x. The domain of this is very similar to the is exactly the same as the cubic, which goes from negative infinity to positive infinity. The range goes from negative infinity to positive infinity. So both of these have both the line and the cubic have the same domain and range. It increases across the entire domain, and just like the cubic, it does the same. Decreasing does not at all. No discontinuities or asymptotes. It has x-intercept of 0, 0, y-intercept of 0, 0. Symmetry for a line is odd. It is odd because if I reflect it vertically and horizontally, I'll end up with the same function. And finally, the end behavior, exactly like the cubic. As x approaches negative infinity, y approaches negative infinity. And as x approaches positive infinity, the y also approaches positive infinity. All right, so the linear function is exactly the same as the cubic function in terms of all its properties, such that if I gave you those properties, you could draw one or the other, and I would have to accept either or graph. All right, on to the next function. Okay, so for this function,